listen. I am B. Nandakishore. My roll number is 2151804A9. I am from ECEB section. My topic is demonstrate unrolled linked list. Introduction. In a computer programming, an unrolled linked list is a variation on the linked list which stores multiple elements in each node. It can increase cache performance while decreasing the memory overhead associated with storing list metadata such as references. It is related to the B tree, and this is a model. The in the maximum in this model, the maximum number of elements is 4 for each node. Overview of model. Record node bracket node next references to next node in list. Int number of elements in this node up to max elements. Array elements an array of number of elements with space allocated for max elements bracket close. Each node holds up to a certain maximum number of elements, typically just large number enough so that the node fills a single cache line or a small multiple thereof. A position in the list is indicated by both a references to the node and a position in the elements array. It is also possible to include a previous pointer for an unrolled doubly linked list. To insert a new element, we find the node the element should be in and insert the element into the elements array, incrementing number elements. If the array is already full, we first insert a new node, either predicting or following the current one and move half of the elements in the current node into it. To insert a new element, we find the node the element should be in and insert the element to the element array, incrementing number elements. If the array is already full, we first insert a new node, either predicting or following the current one and move half of the elements in the current node into it. To insert a new element, we find the node that element should be in and insert the element into the element array, incrementing number element. If the array is already full, we first insert a new node, either predicting or following the current one and move half of the element in the current node into it. To remove an element, we find the node it is in and delete it from the element array. Decrementing number element, it is reduces the node to less than half full. Then we move element from the next node to fill it back up above half. If these elements the next node less than half full, then we move all its remaining elements into the current node, then bypass and delete it. To remove an element, we find the node it is in and delete it from the element array. Decrementing number element, if this reduces the node to less than half full, then we move elements from the next node to fill it back up above half. If this leaves the next node less than half full, then we move all its remaining element into the current node, then bypass and delete it. Performance. One of the primary benefits of unrolled linked list is decreased storage requirements. All nodes expect at most one at the least half full. If many random insert and deletes are done, the average node will be about 3/4 full, and if inserts and deletes are only done at the beginning and end, almost nodes will be full. Assume that one of the primary benefits of unrolled linked list is decreased storage requirements. All nodes expect at most are at least half full. If many random inserts, all deletes are done, the average node will be about three quarters full, and if inserts and deletes are only done at the beginning at the and end, almost all nodes will be full. Assume that m equals to max elements. The max number of elements in each elements array. V equals to the overhead per node for references and element counts. S equals to the node, the size of a single element. M equals to max elements, the max number of elements in each elements array. V equals to the overhead per node for references and elements counts. S equals to the size of a single element. Then the space used for n elements varies between display style v or by m plus n s bracket close v by m plus s and display style 2v by m plus s bracket close n 2v by m plus s. And for comparison, ordinary linked lists require display style v plus s and v plus s and space, although v may be smaller and arrays. One of the most compact data structures requires display style sn space unroll linked list. Lists effectively spread the overhead v over a number of elements of the list. Thus, we see the most significant space gain when overhead is large. Max elements is larger elements are small. Then the space used for n elements varies between display style v by m and n v by n plus s bracket close n v by n plus s bracket close n and display style 2v by m plus s 2v by n plus s into n. For comparison, ordinary linked lists require display style v plus s into n v plus s into n space, although we may be smaller and arrays. One of the most compact data structures require display style sn space unroll linked list. Lists effectively spread the overhead v over a number of elements of the list. Thus, we see the most significant space gain when overhead is large. Max elements is large or elements are small. If the elements are particularly small, such as bits, the overheads can be much as 64 times larger than the overhead on many missions. Moreover, many popular memory allocates will keep a small amount of metadata for each node allocated, increasing the effective overhead v. Both of these make unroll linked lists more attractive. Because unroll linked list nodes each stores a count next to the next field, reiterating the kth element of an unroll linked list can be done in n by m plus 1 catcher misses up to a factor of m better than ordinary linked list. Additionally, if the size of each element is smaller compared to the cache misses, then order linked list. In either case, operation time still increasing linearly with the size of the list. Because unroll linked list nodes each store a count next to the next field, reiterating the kth element of an unrolled linked list. Indexing can be done in n by m plus 1 cache misses up to a factor of m better than ordinary linked list. Additionally, if the size of each element is small compared to the each cache line, the list can be transferred into order with fewer cache misses than ordinary linked list. In either case, operating time still increases linearly with the size of the list. Because unrolled linked list nodes each store a count next to the next field, reiterating the kth element of an unrolled linked list. Indexing can be done in n by m plus 1 cache misses up to a factor of m better than ordinary linked list. Additionally, in this size of each element is small compared to the cache line size, the list can be transferred into in order with few caches misses. The ordinary linked list in either case operation time still increasing. Uh, linearly, linearly with the size of the list. Related data structures. Both stacks and queues are often implemented using linked lists and simply restricted the type of operations which are supported. The skip list is a linked list argumented with layers of pointers for quickly jumping over large number of elements and then descending to the next layer. This process continues down to the bottom layer, which is the actual list. Related related data structures. Both stacks and queues are and often often implemented using linked list and simply restricted the uh, type of operations which are supported. Skip the skip list is a linked list argumented with layers of pointers for quickly jumping over large number of elements and then descending to the next layer. The process continues down to the bottom layer, which is the actual list. Related data structures. Both stacks and queues are often implemented using linked lists and simply restrict the type of operations which are supported. The skip list is a linked list ornamented with layers of pointers for quickly jumping over large number of elements and then descending to the next layer. The process continues down to the bottom layer, which is actual list. A binary tree can be seen as a type of linked list where the elements are themselves linked lists of the same nature. The result the result is that node may include a reference to the first node of one or two other linked lists which together with their contents contents from the subtrees below that node. A binary tree can be seen as a type of linked list where the elements are themselves linked lists are of the same nature. The result is that each node may be include a reference to the first node of one or two more linked lists, which, which together with their contents from the subtrace below that node. An unrolled linked list is a list which with each node contains of an array of data values. This leads to improved cache performance since most more list elements are continuous in memory and reduced memory overhead because less metadata needs to be stored for each of the lists. An unrolled linked list is a list in which each node contains an array of data values. This leads to improved cache performance since more lists and continuous in more memory and reducing memory overhead because less metadata type needs to be stored for each element of the list. A hash table may use linked list to store the chains of items that has to the same position in a hash table. A heap shares some of the ordering properties of a linked list, but uh, but but is almost always implemented using an array instead of references from node to node. The next and previous data indexes are calculated using the current data's index. A hash table may use linked list to store the chains of items that has to the same position in the hash table. A heap shares some of the ordering properties of a linked list, but is almost always implemented using an array instead of references from node to node. The next time previous data indexes are calculated using the current data indexes. Conclusion. An unrolled linked list is a linked list in which each node contains an array of data values that leads to improved cache performance. Cache performance since more listed since more list elements are continuous in memory and reduced memory overhead because less matter needs to be stored for each element of the list. And thank you.